Hello class, this is Mr. Lehman. I want to talk to you about Lesson 11 in the Weather Unit. And in Lesson 11, we're talking about Gay-Lussac's law. So far we talked about Boyle's law, which talks about the indirect relationship between volume and pressure whenever temperature is constant. We talked about Charles's law, the direct relationship between volume and temperature whenever pressure is held constant. Our third and final law compares pressure to temperature. Now the key is, once again, is that we got to keep our third variable, volume, we have to keep it constant. And so if volume is constant, pressure is directly related to temperature. So when one goes up, the other's going to go up. If volume remains constant and pressure doubles, temperature's going to double. If temperature triples, pressure will triple. So whatever happens to one will happen to the other. The key is volume is constant, and so what we need to do here when we talk about these problems is realize that we need to be using a different type of container. So we need to talk about things that are rigid. Rigid containers. Volume does not change shapes. So think about objects made out of glass or metal, like a glass bottle. You can seal that off. A metal bottle, such as a propane tank, aerosol can. Those things don't change size. And so things that don't change size, the volume doesn't change, and therefore we can see this direct relationship between pressure and temperature. So we have a formula, P1 over T1, initial pressure divided by initial temperature in Kelvin, is equal to the final pressure divided by the final temperature in Kelvin. Alright, so if I give you some numbers here, if we have a, let's say, a can, a spray deodorant can, and our spray deodorant can, let's assume, starts out at a temperature of 300 Kelvin, a little bit warmer than room temperature, and inside the can of compressed air, we have a pressure of 2.5 atmospheres. If we take this can and we chuck it into a campfire, chuck this can into a campfire, temperature is going to go up. If the temperature goes up, let's say the temperature triples, goes up to 900 Kelvin, what's going to happen to our pressure? And so we can plug these numbers into a formula here. The initial pressure of our can, the air inside the can, is 2.5 atmospheres. The initial temperature in Kelvin is 300 Kelvin. If it was in Celsius, I would have to add 273 degrees to it to make it Kelvin. We have to use Kelvin in temperature when doing these problems. Our final pressure we do not know, and our final temperature is 900 Kelvin. So we got proportions set up. We need to cross multiply. So we cross multiply, we get 2.5 times 900 is equal to 300 times our final pressure. And if we solve for P2, our final pressure, it would be 7.5 atmospheres of pressure. Temperature tripled, pressure tripled. And so eventually this can is going to reach a point where it can't withstand the pressure inside and it's going to explode. Alright, so I hope this helped with Lesson 11. Have a great day.